Hi, everyone. Okay, this is a lot of people. This is great. I'm hoping that you aren't all completely exhausted by lunch. It was delicious. Hopefully there's a little bit of energy in there still, and we'll get through this talk. I think there's going to be a few things in here that are useful for you no matter how deep down this rabbit hole you've been of debugging. And yeah, let's get started. I think I've been introduced enough. There's not much more to know about me before we get started. So yeah, let's go. Cool. So the first thing I want to talk about is the psychology around debugging, because this is a really interesting area, actually. And often as web developers, we don't really stop to think about how we debug. And it's easy to forget. It's actually a difficult skill, learned over time, and it's to be mastered. It can be improved with experience and more knowledge. And this becomes particularly clear when we compare junior developers with more senior developers who have had more experience, because the junior developers will dive straight into the code in the hopes that something will work. And often they don't really realize what they've changed or what was it that even fixed the problem. You know, that magical like, oh, it just fixed itself. Yeah, I don't know what I did there. Yeah. So this is something that we do every single day. So why do we not spend more time on it? Well, this talk was born out of that question. How can we improve those fundamental skills? So the advice to be methodical sounds pretty obvious, but I bet many of you do forget to do this, at least occasionally. I know I certainly do. Next time you're debugging something tricky, try this out. It may sound kind of familiar, maybe from high school. It's sort of the scientific method-ish. Essentially, we're doing the same thing as a science experiment when we debug. We first outline our problem as a problem statement, and then we come up with a testable hypothesis, a possible reason for the bug. We test that hypothesis, observe the results, and then we choose another hypothesis, and so on until we have a proven theory or a fix for the bug. And what typically happens when we don't do that sort of scientific method, we end up in a mess where we simply attempt to test multiple hypotheses all at the same time. Therefore, you're not sure what still needs to be changed, what you have changed, what fixed it. And if you go through each hypothesis individually, eliminating all the other variables that could be part of the problem, you'll reach your solution much more quickly and more confidently. And that research around the psychology of debugging is really fascinating, particularly around the idea of having a successful mindset. So essentially, a person with a fixed mindset is someone that has the view that intelligence is a fixed resource. It's something that can run out. It's something that you sometimes reach solutions that are just simply outside of your ability. If you're trying to fix a bug that you don't think you have the intelligence to fix, well, then it's not surprising if you get easily stressed, you give up quickly, and be more likely to blame other people. Whereas someone with a growth mindset is more likely to collaborate, be more likely to ask questions, be honest, have a really strong desire to learn, and in the end, be more likely to fix the bug more quickly. So it's very easy to scoff and say, oh, well, we're all in the second bucket, right? Well, no. Have you ever heard of the idea of the 10x engineer? So this is a really popular concept that sort of says that someone can be naturally, at an order of magnitude, 10 times more effective than the normal engineer. And how often have you heard or said, well, I'm just not good at CSS, or I'm just a little bit slower than other developers? It's really easy to internalize that feeling that if something is hard for you, then you must not be good at it and never will be. But being aware of that mindset is the first step to changing it. Embrace those bugs. Learn something from them. Improve your processes. Ask for help and celebrate the wins. Okay, so the polls are in. As you can see, I'm sure you guys will reflect this as well if we were to ask the audience. The large majority of web developers still use console.log the large majority of the time. And it makes sense. I mean, we've been conditioned to use it alongside simple text editors like Sublime Text, Atom, Notepad, etc. And a large portion of web developers have simply missed the exposure to a formal or more structured debugging process. And the browser console is a pretty nice way to inspect the results of your log. So don't really need anything else, right? Well, there are a lot more other ways of doing this. Even if we just take a closer look at console.log, you'll see there's ways to optimize it. Here on the top, we have the normal console.log usage for these two variables, pin1 and pin2. And you can see, okay, they spit out the two words, the values of those variables. Whereas on the second example here, we are logging it out as an object. And I mean, there's just two additional characters here, but now we get the value of knowing what the name of the variable is and the value of it. It's much easier, and it's really nice, especially when you're logging a lot of stuff in your application. Sticking to the console for now, did you know that there are actually a bunch more methods on that object? I'm going to show you my favorites, but Googling will reveal a lot more. For instance, console.table here is really nice if you've got an array with a lot of content in it and you want to be able to quickly scan and see what's important to you. Next up, we have console.group. So have you ever ended up adding so many console logs in your app that you can't even find the one that you just added? Well, group and group collapsed are really useful for structuring your logs into collapsible groups, creating less noise in the console for you to analyze. Another really useful function that you can use in the console is the $selector. So it's kind of like the jQuery selector. It's an alias for document.query selector, but in the console. If you include a 0 after it, you get the most recently inspected HTML element or JavaScript object. A 1 gets you the second most recently, and et cetera, until about 4. It's really useful if you want to quickly see what properties or attributes are on a DOM node or JavaScript object. I'm going to take the trip. Okay, yeah. Much better. Okay, console.trace is especially nice if you're working in a new code base and you don't know your way around yet. So here I added a console.trace in this handle filter click function in my app.js file to figure out where it was coming from. And the results of the trace are telling me that it's coming from the handle click function in my filter.js file. Really nice, especially if you're not quite familiar with the code base yet. And console.dir is great when you want to inspect a DOM node, but you want to inspect it as a JavaScript object rather than as its markup, which is what console.log here returns you. So you can access all the methods and see what's available on that DOM node. In Node, though, it is even more useful. So as you can see, console.log spits out our object, and we have this very annoying object thing in the middle here. Not very useful. I really want to see what's inside that object, right? So if I use console.dir and I pass in a couple of pieces of configuration here to say, yep, I want colors, and I also want to see the whole depth of the object, then we get a much nicer view of that variable. So we can see the whole thing. We can see the Latin long properties now on the geo object. Okay, so let's say we've been working with console functions for a while now and we want to step it up. What's next? Well, the dev tools have some other very handy features for debugging. Namely, the DevTools debugger. The simplest way to activate this is by using the debugger keyword in your code. So I've written here in my code locally the word debugger. So when the browser hits that keyword, it will pause the execution of your code and allow you to inspect it. So here we can see the results of what this variable contains. We can also log out local variables in the console. And we can inspect the entire scope of the application at this point in time. And of course, we can, as a traditional debugger allows you to do, step through bit by bit as the code executes. One tool that's almost essential when using the debugger is blackboxing. And this lets us prevent ourselves from stepping into certain scripts when we're debugging code. So here I was debugging a React lifecycle component function in one of my components, and I stepped through into the React DOM library. Not very useful. I'm pretty sure my bug is not going to be in the React DOM library. So I black box the script. The next time I step through this function, I won't hit that script and I'll focus on my application code. You can also include file patterns in the DevTools settings, like I've got up here. For instance, I've just said, okay, I don't want to see anything that's in any of my node modules files, which is really, really handy when you're debugging something with a big framework especially. Another useful trick when you're unfamiliar with a code base is command plus backslash. If you press this shortcut while the JavaScript is executing, it will act as a breakpoint in your code and stop the execution. You'll be able to instantly see what is happening right at the very time that you press that shortcut. The DevTools debugger has a crazy amount of features. I cannot even go into them all, but you'll see a couple more here. So for instance, on the left, we are saying we want to add a breakpoint whenever the user clicks the mouse. On the top here, you can see we're also adding a breakpoint when an attribute changes on this div of info box. So say the value or an ID gets added by our code somewhere, well, we can add that breakpoint to say, oh, okay, this is why it's being added. Cool. And yeah, you can also add conditional breakpoints like we have down the bottom here, meaning your code is only paused when a certain condition is met. This is really useful for when a certain function, say a React render, is called multiple times, but you don't want to stop execution every single time. For instance, the very first time when the API hasn't returned anything yet. So here I'm creating a breakpoint that will only be hit if the results of my API call, essentially this state call here, and it's returning this mysteries object. Mysteries array. I only want to break when there's stuff in that array. Yeah, so I don't care about that first render because I'm trying to inspect the data, so a conditional breakpoint is quite useful. Okay, so what about when you want to actually test some of your bug fixing hypotheses? Well, a really great feature was released this year in Chrome called local overrides. Make sure you first enable it in the DevTools settings, and then we can go to the sources panel and find overrides and click to set them up. And all we need to do now is find a folder on our hard drive, just creating a test folder here, and there's nothing in it. And then give Chrome access to that folder because it's on your hard drive. And then I'm going through here on the Reddit website, I'm looking at their CSS, and I'm going to find this content div. And I'm going to add a background color of, let me think, purple. And now we have Reddit with a purple background. The best part is, if we refresh, once we've saved, the purple change persists. And this can be magic when you're trying to debug a production website. If I close the DevTools and then refresh, it's gone again. And yeah, this approach is really useful for making smallish changes to production websites in particular when you need to fix a bug quickly, but you have a reasonably good idea of where it is, and you don't necessarily even need to have your local environment running. You don't have to even have the original code on your computer. It can be done just about in any computer setup with Chrome. Okay, so what happens if you want to go a step further and make bigger changes that you not only want to persist on browser refresh, but persist to your computer, to your local files? Well, the DevTool also has a very interesting tool called Workspaces. So here's a little app that I made for calculating insulin dosage for diabetics. Note that it's a production app on Heroku, sugars.herokuapp.com. Don't go there and judge it, it's half finished. Anyway, so we're going to click now into the File System tab and add the folder that's on my local drive that is the code for this website. Again, allowing Chrome access to it. And now I can make changes in the DevTools. Obviously here I'm just going to add a console log, but you can do whatever you like. And you'll see that when I save and go back to my code, it's there. Ooh, magic. Even better, if I go back the other way, it also works. So now I change it to hi everyone, and I didn't even refresh. Like, it just appeared. Again, pretty magic. This can be incredibly powerful. And in fact, for some people, it allows them to use Chrome as their only IDE. For me, that's a little bit scary. I'm probably not quite ready for that. It can be a little flaky, and it's still not as good as a full IDE, in my opinion, but it struggles a lot with really technical build systems, and it doesn't support, say, Create React app, for example. But it can be very handy. And if you like this idea of being able to persist changes on your hard drive, on your production website, on your hard drive, there's one last way I want to show you. This is the concept of proxying your production files to local files on your hard drive. Similar to workspaces, but without the DevTools persistence, and with a lot more other features that better support those complicated build systems. The simplest is a Chrome extension called Resource Override. So this is it down here on the bottom. Say you have a version of your application running on localhost. Okay, using this extension, you could proxy that call from this particular production file here, bundle.js, to the bundle.js that's on my local host. This means that when you refresh the website, it's loading your local version of bundle.js, allowing you to change your code and test it within the larger environment where the bug actually occurred. Applications like Fiddler and my favorite Charles Proxy, also written by a Kiwi, also allow you to do this, but with a lot more features, including the ability to monitor and inspect all the calls that your site makes, and also fake SSL certificates and all sorts of other complicated things that you might have in your website. I've been on teams that have literally used Charles Proxy for their entire front-end development flow. Many big applications can be tricky to set up locally, and trying to keep the back-end architecture and APIs up to date, as well as your own front-end across multiple teams, potentially across multiple countries, can take a lot of time. If, however, you have a really reliable staging environment, then proxying your front-end files is a really nice way to you can skip that whole setup entirely. So a lot of the technology that I'm covering is either seriously enhanced by or doesn't work at all without source maps. So a quick refresh. A source map is a file that allows the browser or other technology to map the compiled and or compressed code back to its original file. It's another really important tool that helps with debugging. Minified code is pretty much impossible to debug properly. So on the top, we're inspecting a website without source maps. And you can see all the variables have been mangled down to a single character. And the ES6 class has been transpiled down there as well. Whereas on the bottom, source maps have been set up. You can see, well, it's actually my code that I wrote. So much easier to debug and figure out. And depending on your build process, it should be pretty straightforward to set up. Here's the config for Webpack, for example. At the top is the way to tell Webpack to use its standard development configuration, which actually includes source maps by default, includes a whole bunch of other stuff by default. So if you haven't got anything complicated, just use that and you're good. If you want more control, you can define it separately. I've chosen cheap module eval because I like the balance between speed and support, the types of source maps that it creates for you. But your choice will depend on your use case, and the documentation is really good. Then beneath that, we have the config for production. So the only thing, again, you really need is the DevTool property. But if you're using uglify.js to minify your code, you'll want to set source map to true when you declare that plugin. And if you want to set the file name of your source map, you can do that here too. When you build your project, you should see your source map file appear, like we have on the right. iot.min.js is obviously my actual JavaScript. iot.js.map is the source map. So what about deploying source maps to production? Well, I'm a big believer in doing this because production bugs are when source maps really come into their own. The good thing about source maps is that they're only downloaded when the DevTools are opened, so they have no effect on your application or its performance. And if you're really worried about people being able to look at your source code unminified, which some people do get worried about, keeping in mind that they will always easily be able to prettify your code in the first place, so you're not really giving them that much. But anyway, there is a straightforward solution. You can indicate in the JavaScript file a source mapping URL, which is configurable with Webpack, and it points to the source map that has been uploaded to a different location, which can be only accessible by your team, so maybe your VPN or your IP address or whatever. Say an S3 bucket that you can control. And yeah, that's how to do it in Webpack. Okay, moving on now to performance debugging. I don't have time to fully do it justice because there is just so much you can learn about here, and it's easily another entire talk. But I wanted to quickly illustrate that it doesn't have to be as scary as this flame chart can look to people who haven't explored it yet. The key is to find your code in the flame chart. You'll start to feel a lot more at home. If you click to open the main panel, you'll see all the activity that occurred on the main thread, including the execution of JavaScript. Usually a lot of the content here is found in frameworks, but if you scan through these orange sections, you'll be able to find your personal JavaScript files, which is usually what you're looking for. In my case, it's my main.js file, main.js. Note that this is a very basic one-page app, which is why it's so small. You can then zoom in further and find the functions in your app and compare the time that they're taking with each other. So here we can see a call to append child and fetch, which should be a lot more familiar to us. The easiest and most effective way to debug an app's poor performance, however, is by doing a performance audit by using Lighthouse, which Katarina very kindly illustrated to us before. In case you weren't in that talk, it's a very easy tool inside the DevTools where you just go to the audits panel and you can click through and it will give you a whole heap of good ideas of how you can improve the performance of your app. So this opportunities section is my favorite. It just says like, here, you need to do this, 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 and you'll have a faster app. Really nice and easy to follow. So the last thing for the DevTools, did you know that you can even debug Node in the DevTools? You just need to run your Node script with the inspect flag. BRK at the end here, by the way, means break before the code starts, so you can add your breakpoints straight away. And then either click on this green Node icon in any DevTools window, or go to Chrome/inspect and click on Open Dedicated DevTools for Node. If you really like this workflow, you should check out the Node Inspection Manager extension, which manages all your scripts and windows for you. Okay, so to the really good stuff. Integrated debugging in the editor has been around in various forms for ages, but many JavaScript developers are either not aware of it, they think it's too tricky to set up, or they don't want to change their debugging mindset because they don't think it's worth it. Well, I'll let you be the judge, but just promise me that you'll try it first. Fortunately, we have a lot more front-end focused editor options now, some of which include an inbuilt debugger. I'm going to focus on VS Code here because it's super light and it's fast and it's what I use every day, and I'm not trying to sell you anything. That would be stupid because it's free, but yeah, other IDEs like WebStorm also include an inbuilt debugger, and the idea is pretty similar. So I'm going to take you through some of my debugging process and how I set it up with a mini front-end React app that talks to an Express server. I've added a couple of spelling mistakes to simulate a real bug that you might be trying to fix. So a typical process for debugging a front-end application might look something like this. We open the browser, we see an error in the console. We go to the editor, we console log out some of the variables that we think might be causing that error. Back to the browser and refresh, or maybe a hot module reload. And if we're lucky, we've chosen a variable that helps us determine how to fix the bug. Back to the editor, make the fix. Back to the browser. Okay, great, we've confirmed it's fixed. Well, that's a hell of a lot of guesswork and switching back and forth. Let's see how we can improve that flow. So VS Code has a bunch of extensions that let you debug tons of different languages in different configurations. The most useful for us is the debugger for Chrome. It's actually framework agnostic, so you could work with Angular, Vue, whatever you would like, but I'm going to show the configuration for my React app. So first of all, we're going to go and download the extension. And here it is, debugger for Chrome. Okay, great. Reload VS Code. And we're good. So we can now go to the debugger and add a configuration. And here our new Chrome configuration is included, and all we need to do now is change the port, the default port, to 3000 because that's what Create React App uses. If we save that, we can now press play, and you'll see that it has launched a window with my beautiful little app. And the cool thing is that that's it. There is absolutely no other setup or settings. So if you've ever thought like, oh, this is going to be way too hard, if it's a simple app, it's really easy to set up. If it's more complicated, there are a lot of different options that will allow you to achieve the debugging in the browser as well. So the actual debugging, well, it's really nice. So here we have a bug where on my website there's supposed to be quotes from each of these books showing up. And so if we go and look at the code, we can add a breakpoint to our render method. And then as we enter the debugger, we can step through that code. You can see, oh, quot is undefined. I wonder why. If we look at the scope on the left here, we can go check out the state and see one of our mysteries. Ah, quote. Quote is spelled with an E on the end. Okay, great. Let's fix the bug. And remove the breakpoint, refresh, and magic, fixed. So without even touching the browser, it's all fixed. Obviously, this is a pretty fake example, but you get the idea. And a similar situation occurs with Node. So a typical workflow, if we're dealing with a Node API, might be something like we start with an error in the terminal this time. We switch to the editor to write a console log to check a variable. We switch to Postman or another terminal to run curl, or a browser to run our app, however we want to hit the endpoint. We switch back to the terminal to see the results. And if we're lucky, we can write a fix for it. Hit the API again and hope that our bug is fixed. Again, we can really clean up this workflow by doing so much more in the editor. Here's how to set it up. Okay, so here we have another bug. The API is not returning anything. Not very useful. In this time, we're going to add a configuration that comes default with VS Code called the node launch. And this time, I don't even have to change anything because my app is at app.js. So now when I press play and I come down to the terminal here and I just run curl to ping my app, you can see that it's responded with Pong. So you can see that it's running. Once we have the debugger running, we can hit this broken mysteries endpoint with our React application and easily debug what's going on in our Node API. So if we refresh the application, we've hit our breakpoint. We can inspect the request, the base URL for our endpoint. That all looks good. Okay, let's step through. This looks good. Oh, we've hit an error. Interesting. Error. Okay, Misters is not defined. I wonder what's wrong. We come back. Okay, great. It's just spelt mysteries. Okay, we could have figured that out. If we refresh now and then hit the API again using our app, you'll see it's fixed. What's even cooler is that VS Code will let you make compound configurations. So you can even debug your front and back end at the same time over multiple and different languages even and frameworks. So before I finish, I should just quickly mention that in no way have I covered this space. I've obviously had to focus on one browser and one IDE, and I didn't even touch on mobile accessibility and HTTP debugging, to name a few things. There's so much more to explore here. And of course, accurate and realistic test coverage is an extremely important and useful way of preventing bugs in the first place. The golden rule is once you fixed a bug, make sure there's a test for it. I'm hoping you guys know that one. So the last thing I'm going to leave you with is this. If for some reason you're going to stick with the good old console log, that's fine, I won't blame you, but please make sure you at least set yourself up with a good code snippet so you're not constantly typing console.log all the time. So here's a little snippet I have. When I press tab, it fills it all out, and I can just type in the variable and it spits it out for me. And that's it. Thank you guys so much.
Thank you, thank you, thank you.
You're most welcome.
Right. Okay. And you're going to be taking a little plant home with you?
I am, yeah.
Yeah? A little
is
olive
exciting.
branch to grow
Cool.
at
Thank you.
home. Do we got time for some questions?
Yeah, if
Yeah?
anyone's got questions.
Okay. So, hands aloft. Who wants to ask Rebecca? Come on, don't expect me to ask questions because I didn't understand any of it.
I'm hoping some of you guys understood that.
Right, okay.
All
Well,
right.
I actually, I checked out on my new favorite site that there's how many of me, I mentioned this earlier, howmanyofme.com to find out how many people in the US and the UK, I haven't found it for the world yet, but how many people there are with the same name. And in the US, there's 1,077 Rebecca Hills, and in the UK, there's 270. But I think we've got to give it to her. We got the right one here. The only one that counts.